Hello, everyone, and thank you for joining us today for this open text webinar, Three Common Pitfalls in Continuous Integration / Continuous Delivery and How to Avoid Them. My name is Melissa Juarez. I will be hosting today's event. I've been with OpenText for almost 5 years as a product marketing manager, and I currently support our DevOps and value stream management platform, ValueEdge. I'm pleased to be joined by our featured speaker for today, Julian Fish. He is an expert in the dev space, and I'm excited to hear his thoughts on CI/CD. I'll let him go ahead and introduce himself in just a moment. But before we begin, I just need to cover a couple of housekeeping items. You'll notice on your console window, there are multiple engagement windows. All of these windows are movable and resizable, so feel free to move them around and get the most out of your desktop space. You can expand the slide area or maximize it to full screen by clicking on the arrows in the top right corner. We also encourage you to ask questions at any time during the webinar, which you can submit through the Ask a Question box. We will have a live Q&A session at the end of the webinar with Julian. So go ahead and engage and ask any questions that you have that come up throughout, and we'll answer them at the end. Please note that we will capture all of the questions, so even if we run out of time, we will answer your questions later through email. I'd like to let you know also that we will have some polling questions during the webinar. So we're very interested in hearing your thoughts on CI/CD and how it fits into your existing or future DevOps practice. So I hope you'll let us know how your thoughts and what you think when we get to that part in the presentation. For the best viewing experience, we encourage you to use a high-speed and stable internet connection and close any programs or windows or browser sessions running in the background that could cause issues. Keep in mind that events are bandwidth intensive, so closing any unnecessary browser tabs and logging off your VPN will help to conserve your bandwidth. If your slides are behind, try pushing F5 on your keyboard and that will refresh the page. You can find additional answers to common technical questions in the help tool at the bottom of your screen. A recording of the event will be available after the event concludes and can be accessed using the same audience link that we sent to you earlier. All right, let's get started. I'll hand it off to Julian.
Well, thank you, Melissa, and good day, everyone. Welcome to today's webinar. My name is Julian Fish. I'm Director of Product Management here at OpenText. I've been with the company for almost 24 years at this point, and at the moment, my responsibilities lie in the area of DevOps and DevOps transformations for our customers, taking care of everything from software change, configuration management, code control, all the way through to deployment to production and everything that happens in the middle. And part of that everything that happens in the middle will be discussed in quite a bit of detail, I hope, and hopefully in a quite interactive way for the next 45 minutes or so. Just as a reminder, Melissa mentioned this, but there is a Q&A panel to the right of your screen. Feel free to add questions into the Q&A panel. As they pop up on screen, I'll do my best to answer them. And we'll also have a dedicated question and answer session towards the end. But without further ado, let's talk a little bit about continuous integration, continuous delivery, the pitfalls that we see with our customers, the pitfalls that we've seen over the last 12 or so years, or actually, wow, it's time flies by, the next 15 or so years since DevOps really came to the fore, and how we can try to avoid them. Let's talk a little bit about the world of DevOps. The traditional world that we probably don't even remember anymore, but some of us are still transforming away from, was a very, very slow process of getting change from an idea into production. The realities of traditional waterfall ways of working, or V-model ways of working, or spiral ways of working involved iterations of code that took a very long time. Going from maybe a functional design through some kind of detailed system design to some code change to some associated system tests, through some associated integration tests, through some associated user acceptance tests, and out to production. And those processes for delivering change and the vehicles for delivering change were pretty long-winded. When I first joined the OpenText company 1,000 years ago, customer releases that I used to work on would take anything from 18 to 24 months. If you put that into today's execution timelines, I'd expect most high-performing organizations to deliver at least 24 releases during that 24-month period. For the true high-performing organizations, let's take 24 months and times that by 30 days and end up with a large number, probably around 700 and something, numbers of actual days of releases. And every single day, a lot of the high-performing organizations out there release software. So how do we get from that traditional waterfall model to the day-by-day, change-by-change, feature-by-feature release processes that we see now? Well, the folks like Jim Key, Gene Kim, Patrick Dubois, Jez Humble, David Farley, John Willis, all had a huge influence in the mindsets of organizations and organizational leadership, especially when Patrick Dubois came up with the notion behind DevOps. This combination of cultural philosophies, practices, and tools to allow organizations to foster collaboration, communication, and integration across their organizations. The reality is when we took a dev organization and an ops organization and we munged them together in the intent of trying to speed performance, we certainly introduced some challenges, but we saw some significant benefits. Being able to take a change from ideation through to production in a matter of hours rather than a matter of months made a huge and continues to make a huge difference to the digital transformation that's happened to organizations. So through DevOps, we've seen a real streamlining of process. We've seen a real increase in the velocity and the ability of organizations to increase the velocity of their application, product, or code deliveries. And we've seen the shift from long-winded release cycles to continuous delivery processes, or maybe even continuous deployment processes to get applications into production environments as quickly as possible. And when I say applications, change to applications into environments as quickly as possible. So this whole notion of DevOps contains a number of different capabilities. That could be everything from agile transformation, implementing agile processes for tracking the change that's taking place to your organizational applications. For example, it could be a ticket in a system like a Jira, or a ticket in a system like a ValueEdge or a ALM Octane, or a ticket in a system that's driving change through GitHub or GitLab. This whole notion of the change ticket tied into the developer, the software engineer, making the change as quickly as possible, and then pushing it into an environment where it can be suitably tested, introduces the notion of continuous integration, that change constantly being pulled into the application and validated, and then the notion of that change being deployed into environments in order for it to be tested and ultimately running in production. So DevOps, this notion of people, process, culture, and tooling change allows us to streamline our end-to-end delivery and allows us to simplify the delivery of change. And that's what we're really managing here, this organizational change, this application change through our end-to-end delivery processes. If we take that notion of delivering change as quickly as possible, there are some real switches to our mindset in our organization that we need to make in order to be able to deliver change as quickly as possible. And there are some tooling changes and some people and some process changes that we need to be able to implement. The drivers behind implementing all of this change, because again, remember, change isn't free. Anytime you make a change, there's a cost. That could be a cost to the organization in terms of changing tools. That could be a cost to an organization in terms of re-educating the workforce. That could be a cost to the organization in increasing the amount of infrastructure that's required to support the new working practices. But those costs can be mitigated by some of the benefits that we see in this transformation process. And when we're talking specifically around continuous integration and continuous delivery, we've got some really good benefits that we can take advantage of. For example, being able to fail fast. That old world that I was talking about, that world of 20 plus years ago when I first joined OpenText and came into the world of true customer-centric transformation, the ability to be able to identify failure points or bad commits of code or bad changes was incredibly expensive and time consuming. Changes were found way after they'd been implemented into the code base. Why was that? Well, because our software builds weren't necessarily happening as soon as the code was committed. With a continuous integration based model, as soon as a developer commits their code to a repository, that could be through a pull request, that could be through a traditional check-in of code, that could be some kind of workspace synchronization. It doesn't matter the mechanism. The trigger of a build from the commit of code is really all continuous integration is. That ability to take that change that's being committed and to build it against the existing code base. Of course, the first benefit of that is we're not waiting for a scheduled time for our build to take place. Again, in the older days, maybe a build only happened once a day or once a week. By building every code commit, we can fail fast. We can immediately identify if any code changes break our build, or we can identify if any code changes don't pass our testing. We can immediately identify if we can't deploy that configuration, that code, that new build of the system into an environment. So failing fast is one of the key benefits of continuous integration and continuous delivery. The faster we can identify problems, the faster we can remediate them, the less impact they have in the long term. We're able to make small incremental changes and push them into our environments. Another way of describing that is shift left. We're able to shift our testing and our deployment processes left to identify changes and challenges as quickly as possible. When we talk about continuous integration and continuous delivery, this whole DevOps transformation piece, we're also talking about how we get an application from the ideation phase through the code phase and into our testing and our production environments. Now, that notion of going from code to test to deploy is defining logically a pipeline. A pipeline is simply a step or a list of steps that take place in order to get our application from some kind of code change into production. Continuous integration and continuous delivery practices allow us to support pipelines. And those pipelines could be incredibly simple. It could be build my code, test my code, and hold on to my code in some kind of location. They could be incredibly detailed. It could be build my code, but before I build my code, scan my code to make sure that it adheres to the standards that are put in place for my organization. Once I've built my code, make sure that there are no third-party dependencies that shouldn't be in that code. Let's make sure that my scans of my security settings, let's make sure my scans of my dynamic or my static analysis testing are performed. Let's make sure that when I deploy that code into some kind of testing environment, I can run my API tests, I can run my formal user acceptance tests. Those pipelines could be incredibly complicated, but incredibly powerful. The key around pipelines is not only do they simplify that process of going from dev code commit to production, but they also make it repeatable. In the old days, getting code from one environment to another was a manual set of activities and tasks. Using a CI/CD, continuous integration, continuous delivery approach, we automate as much of that as possible. We're taking our applications from environment to environment, or we're building those applications into some kind of system, maybe using containers, maybe Docker, maybe Kubernetes, and a scaled system to be able to deploy them immediately through our environments. The key being automated, repeatable, and subject to approvals to allow them to move through the environments as every other change that's going through the system gets delivered. And then, of course, we can talk about things like feature flags and dark support for launching of individual features. We'll talk about those later on. So failing fast, looking at pipelines, and of course, building security into the process. Traditional security models were built in a way that code commits happened, builds happened, and after the builds had happened and some initial testing had taken place, we were looking at security teams to come in and run verifications. That could be security of the scalability of the product. That could be security of the systems from a dynamic or a static security scan perspective. That could be all kinds of penetration testing that's going to happen. That could be vulnerability scanning. That could be all manner of different security aspects. Historically, a lot of those steps took place after we built our software by including security scans and peer reviews and code style and vulnerability scans into our CI/CD pipelines. We introduced the notion of DevSecOps, building security into our systems, building security into our processes. And of course, that also ties into this notion of failing fast. If we identify security issues as early as possible, we don't have to go through the complex and costly process of rebuilding our applications way after they've been deployed to environments. In the traditional CMM models, going way back, the Software Engineering Institute defined with Carnegie Mellon University almost 40 years ago at this point. There's a great little chart that explains the cost of fixing software in different phases of the life cycle. All I'll say is finding a defect as soon as it's being created costs one time. The amount of resource and time that it would require to fix it. Basically, we're fixing that defect straight away. The further through our environments, the further towards production we get with that defect, the more costly it gets to address. By the time we get to production, it's 256 times more expensive to address a problem than it was if we found it initially in the requirement or in the definition of the work that we were doing. So the faster we can fail, the faster we can identify problems and issues, deploying through our pipelines, applying our DevSecOps practices, the cheaper it is for our organization in terms of time to rework, in terms of investment in resources that are working against it, in terms of the environments and the applications that we're deploying it to. Failing fast, defining our pipeline support, and working in a DevSecOps manner. Now remember, the Q&A panel is there. If anyone has any questions as we're going along, feel free to drop questions in and we'll do our best to address them. Remember, when we drop continuous integration and continuous delivery, it's not a simple just put some technology in and expect everything to work. There are some big risks around CI/CD and delivery. Now, in my mind, delivering applications using a CI/CD model are incredibly beneficial and way more beneficial than the risks that we'll talk about. But hey, let's talk about the risks. It's important to know about the challenges that we'll face. So let's talk about complexity. In a single application world, life is nice and easy. Think of the organization that you work for and think of the number of applications or products that you deliver. I'm guessing because on these webinars, we normally tend to have individuals who work for enterprise organizations. You don't just have one product or one application that you're working against or that your company is working against. Those organizations where there's a single product and it is the company, they don't tend to last very long. They tend to be very niche and they tend to either get acquired by other organizations or they tend to diverge and divest into different areas. The reality of large enterprise organizations, highly regulated large organizations, is that you have many applications and you have many applications that are interdependent upon each other. To take a simple example, you may have a mainframe that takes care of a load of back-end processing and a bunch of distributed applications or applications running in containers or in modern architectures that eventually communicate in with that mainframe to retrieve data and to push information. Even simple three-tier applications where you have an application server, a database, and a front end, there are dependencies between those different components. So one of the big risks is complexity. How interconnected are your applications, teams, and processes? Because that'll reduce the ability to be able to implement fully fledged continuous delivery practices. You can't release an application to production if another application is dependent on it and you need a change from that other application to take place. Another key area for highly regulated large enterprises is looking at sign-off. In a lot of organizations, you can't just simply deploy changes to production. I could hear a lot of people pretty smiling at that whole notion, being able to take an application change or a product change and just saying, hey, let's just push it into production. You need sign-off to take place for the application to get into production. Why do we need sign-off? Well, a lot of the time it's because of regulatory compliance. Even in the decade that we're currently living in, a lot of organizations aren't physically allowed to deploy applications to production without some form of physical sign-off to take place. Why? Because they believe that it ties into regulatory mandates. For example, in the financial services sector, there's certain capabilities around Subox that would prevent you from doing something without segregation of duties. There are requirements in the DoD space, for example, or the automotive space, where we're supporting 2626.2, where we need to think about how applications are deployed and segregation of duties. So having a single person take the code base from one environment all the way through to production just isn't possible. The other component is, of course, that dependency, the complexity dependency, making sure that we're signing off all of the different applications that have been delivered at the same time so they can all go to production together. And then, of course, the complexity of distributed teams. I'm very lucky in the organization within OpenText that I have teams that work in multiple regions. That's teams in Europe and different countries in Europe, teams in North America, and so on. Those different teams have to work cohesively, and they have to be able to understand exactly where everyone is within the code base, but also within the end-to-end set of features and capabilities that we're working on. So complexity is a big, big driver for CI/CD. How do we simplify the complexity away from the process and away from the systems and the people, process, culture, and tooling? The second thing to think about is scaling. Take a moment to think back to something I mentioned 10 minutes ago. This traditional world where maybe we were building once a day or we were building once a week. Now, in order to build once a day or once a week, it's pretty straightforward. You need a set of infrastructure that can be available and you can build against it. And if your tests take 5 hours to run, you know that your tests are going to be running for 5 hours and that infrastructure is going to be used. Well, let's fast forward to today where we're running a build every commit and we're still trying to run our tests at the same time. Now, of course, if we're building and committing or building on every commit, what does that mean for our infrastructure requirements? Well, if I need dedicated infrastructure for my tests, and even if I have 3 developers and they all make 1 commit a day, that means I need 3 sets of build infrastructure. Why? Well, if my tests are going to run for 5 hours and I commit my code 3 times, there may be overlap between them. How does my system cope with multiple changes being deployed into that same environment? So in order to scale successfully, you need to think about your application structure. You need to think about your application builds and your tests and think, how can I include the amount of infrastructure that I need? Like I said, for some applications, that could be a different build system for every user who are building and testing using their code commits. Or that could be that we simplify our application architecture, we simplify our build processes, we make our applications much, much more granular, and we perform testing just against those individual components. Of course, when we're building and testing, we also need to think about automation. How do we automate our tests? How do we make sure that we have full scalable automated tests for our APIs, for our performance testing, for our user acceptance testing, for our functional testing? But then how do we make sure we can automate the deployment of our changes into each of the different environments that we need to go through? So scale is a big risk, and it can be expensive. We can introduce a demand for a lot of net new infrastructure. That could be physical infrastructure, virtual infrastructure, cloud-based infrastructure. Either way, it doesn't matter. It still has some kind of intrinsic cost aligned with it. And then, of course, the final one, the one which is probably the most challenging of all, technology you can adopt. Scalability you can adopt. Complexity you can simplify. Changing organizational cultures is a much more difficult undertaking. Organizations have to shift to a change-enabled mindset. What do I mean by that? For a lot of organizations, especially large enterprise organizations, there is a status quo mindset. There's an idea and a notion that the way things work today are the way things should be working because that's the way they've always worked, and change is bad and change is dangerous, and change introduces risk. Now, there is an element of truth in that statement. Every change that we make to a system or to a process or to the working practices of individuals introduces risks. The key is to make sure that the benefits outweigh the risks. If we're defining new processes for our applications, we need to understand why the current process is defined the way it is. That could be related to the fact that the application is maybe an older application and it needs to build a certain way, and it needs to include certain dynamic library pulls. Maybe it's a C++ application and it has a bunch of includes that need to come from certain locations, or reliant upon, like I said earlier, maybe some third-party application or other applications. It could be that we have processes in place because the tooling that we're using doesn't support a more agile or dynamic approach to software engineering. So for cultural change, we need to change the processes and the tooling, but then the mindset of the team as well. The team has to shift to be willing to adopt a new approach to undertaking the day-to-day activities. And I've seen this in a number of organizations. This can be quite a big stumbling block. Again, getting people to change their working practices, where suddenly build failures are flagged up every single time one happens. If we're working in an environment where we're building once a day, it's almost, well, not impossible, but it's very difficult to immediately identify which code changes cause the build failure. It takes us a little bit of time to go through and understand. Where we're moving to a mindset of visibility and openness, and we're moving to a mindset of continuous integration. As soon as a code commit fails, and as soon as Julian commits some code to the repository that causes a build to fail and puts a red flag on everybody's dashboard, it becomes immediately apparent that it's my code change that made the system fail. Now, that doesn't mean that we apportion blame to individuals. It just means that it's much more immediately visible and understandable for the entire team of why the build failed. And there's a cultural and a mindset shift that needs to tie into that. There's loads more challenges with dealing with culture. There's plenty of books written around this that I could recommend, but dealing with the mindset change of cultural shift, and then defining your processes and adopting your net new technologies. Big risks to the way that the organization works. But again, in my mind, this is a big shift that we can make, and some significant benefits that we can make to improve the velocity and to improve the quality of the product lines that we're delivering. One thing we haven't mentioned so far in some of those benefits, that shift left process, that fail fast process, it's ultimately improving your product quality, identifying problems early on. We'll talk about that a little bit more as we go through the slides in a bit more detail. But for now, let's talk a little bit around CI/CD. Now, hopefully there's a few of you still out there who are paying attention. What you should notice is at the moment on the screen, there is a question that's being asked. The question around what is holding you back from implementing CI/CD? So remember, we're talking about continuous integration, continuous delivery. We're talking about getting continuous integration and continuous delivery practices implemented in your organization. Maybe you're already part of the way there. Maybe you're already all of the way there. Maybe you haven't started yet. But as you look at that whole concept and that whole idea of implementing CI/CD, what were the barriers to adoption? And again, there's a submit button on screen. You can click the answer, and that'll allow us to then have a little bit of a discussion around what we're seeing from our customer base or from people out there in the wider world. So the potential options that we have, what's holding you back from implementing CI/CD? Option A, lack of buy-in from stakeholders. So that's the folks who are running the organization or running the development teams, the engineering teams, aren't bought in to the whole concept of CI/CD. Option B is the current tools that we're using are limited or don't have the capability. So we mentioned that a couple of minutes ago, this ability to be able to put the tooling in place to support the teams and the practices that we want to deliver. Or number three, or option C, I should say, when C becomes 3, it's always a little bit worrying, but option C, a lack of knowledge or training for the team. Basically, we're still trying to get our heads around how do we implement CI/CD for our particular applications or our particular products. Okay, so we'll give the poll another, let's say, 15 seconds or so. So if you haven't voted yet, I see we've got quite a few answers already, but if you haven't voted yet, feel free to continue and click the button. That's option A, lack of buy-in. Option B, tools are limited. Or option C, lack of knowledge training. And I guess we'll call it last call for votes. And in 5 seconds, we'll call it done. So and we're done. So let's take a look at the results. The nice thing about the platform that we're using today is that we get immediate responses. Pretty impressive, actually. So we had a pretty broad set of answers there. And considering we had almost 50% of the folks on the call voting, which is a pretty good number for a webinar, I must admit. Much easier in a room when I can ask people directly, but over the webinar, about 50% of folks answered, and of the folks who answered today, what we're seeing, over 3/4 of people lack of knowledge or training for the team, and about a quarter of people lack of buy-in for stakeholders, which is interesting. That lack of knowledge or buy-in from stakeholders indicates maybe some more challenges with the business. What do I mean by that? If your organization itself isn't bought into transforming and delivering the capabilities, my concern is that you'll start slipping behind in your delivery processes, your speed to delivery, your time to market value, because that's the big benefit of CI/CD. It reduces that time to market value, getting your ideas into production as quickly as possible. That 3/4 is either the lack of knowledge or training for the team. We can talk a little bit about that as we get into more details. How do we empower the team to pick up the tools and technologies to deliver? Notice that nobody has a tooling issue, which is always a good answer. Tools shouldn't be the thing that constrain the people, process, and culture challenges that we need to address. So lack of knowledge and training for the team. How do we improve CI/CD practices? Well, let's talk about that now. Everything we're talking about now is about transformation. We've seen digital transformation over the last 10 years become the real buzzword. How do organizations, traditional organization, bricks and mortar organizations that weren't born .com ready or e-ready. Wow, e-ready? I went a bit old school then. But organizations that weren't born as digital natives go about transformation. And when I say organizations that weren't born as digital natives, the likes of the Facebooks, the likes of the Googles, who built from the ground up with technology in mind and are built on a technology platform. For those of us who live outside of that world, those of us who live in a world where maybe we're working for, I mentioned financial organizations, big transformations in place across those, automotive, aerospace, pharmaceutical, organizations where you've been around for a long period of time, but the digital part of the business is catching up with the rest of the organization. Transformation is a journey. It's something that needs to be led from the top down. So that 25% is a little worrying around that. We really need to drive that transformation. But transformation is not something you finally achieve. You continue to optimize your processes. The whole notion of Deming and PDCA and the continuous process improvement, the notions, the SEI and Carnegie Mellon, the CMMI and this 5-step model to process nirvana, and step 5 being process optimization. Optimizing isn't optimized. You're continuously optimizing your organization, and transformation is part of that. You don't ever get to being optimized as an organization. You're never running as fast and as well as you can. There's always tweaks that you can make. Usain Bolt said some interesting things around that when he was at the peak of his powers and talking about how he would make 1% improvements in different parts of his approach to running. When he's sprinting, it could be the work he was doing on the start. It could be the work that he was doing in his breathing. It could be the work that he was doing in increasing his stride length and increasing the velocity of his stride pattern. For him, same thing. It was a journey, not a destination. It wasn't, I'm the fastest man on the planet, I'm done. And it's the same for organizations. Continuing, optimizing and improving your processes, that journey that we go upon. So let's talk a little bit about how we get on that journey and where we go. To take us into this one, we'll talk a little bit about complexity. Now, there's one more question that I've got from a poll perspective before we get back into the content. So if you're still with me and still around, let's talk about DevOps and DevOps toolchains. I talk about DevOps at the beginning, and I spoke a little bit about continuous integration delivery. This number of tools that we have that go from the idea of a code change and the idea of a change that we're making to an application to getting it out into production. That's our DevOps tool chain. Things like agile tools like Jira. There's code management tools like Git or Subversion or Dimension CM, or Perforce or GitHub or GitLab. There's tools that make components of the tool chain. So maybe continuous integration tools, one that a lot of people have heard of, tools like Jenkins, or tools like Circle CI, or tools like Pulsuno, or tools like GitHub who have CI tools. So how many tools make up your DevOps toolchain? Once we get beyond our capabilities of building, we're into the world of verification and testing. That could be performance testing or functional testing or security testing or penetration testing or peer review or code review. How many different tools do you have that go through that part of the process? And then into our more formal release and deployment phases. Do you have tools that take care of the deployment of your code? Do you have tools that take care of the release management function of your organization? Do you have tools that manage your operations system? So I'll mention a few more tools in all of those spaces. So tools in the testing space, obviously tools that OpenText provide, like performance engineering tools like Load Runner, in the functional testing space, UFT, in the security space, tools like Fortify DAST and SAST. Could be tools like Tricentis that sit out there in the testing domain. Tools that have started moving into that space. Again, I mentioned GitLab earlier on. Deployment tools, capabilities like GitHub Actions or deployment automation from OpenText or IBM Urban Code. It's a plethora of tools. And then release management and government tools. Tools like Broadcom, release, tools like the OpenText release management solution stack. So yeah, as we talk through this plethora of tools across the DevOps toolchain, we'll give it another 15 seconds. The options that we had this time, and I'll say the letters, not the numbers. So option A, 1 to 10, option B, 11 to 20, option C, 21 to 30, or option D, more than 30. And we'll give it another 5 seconds. So get your last votes in while you can. And that's it. Time is up. So let's use the magic of the platform and figure out. So interestingly, about half of you between 1 and 10 tools. I'd be interested actually a little bit more detail around that. Maybe if folks are looking at platforms for the end-to-end and what capabilities they provide. Just over a third with 11 to 20, and around an eighth of you having 21 to 30 tools. And of course, for those of you further down the list, we mentioned complexity earlier on. Complexity increases the more tools you have in your DevOps toolchain. It's difficult to standardize the flow of information across multiple tools. It's difficult to normalize reports and data insights and get a true understanding of where we're at. Maybe not from a developer productivity perspective. I think our friends at McKinsey have scared the world around developer productivity for the next 5 years or so for the report that they wrote last year around that. But certainly the more complex and the more interactions we have, the more potential points of failure for our tool chain. And again, the more challenges we have of being able to standardize, normalize, and then report on data. So let's talk of tools and tool chains. What does that mean? I guess when we're talking CI/CD, we've talked a little bit about continuous integration and continuous delivery. One of the challenges when I first started talking to enterprises, some of the biggest financial institutions on the planet that I was working with at the time, there was a lot of confusion around this whole CD notion. When is CD not CD? Well, continuous delivery is CD and continuous deployment is CD. And whilst they sound very similar, there are some subtle differences between the two. When we're starting on this whole process of transformation and we're thinking about the risks and the pitfalls to avoid, we need to make sure our terminology is always standard. Continuous integration, fairly straightforward. We know that we're continuously integrating our software changes. We're taking our code, we're committing it to a repository, we're triggering a build, our build happens. Maybe it's just the build that happens. Maybe there's no extended pipeline from there. That's continuous integration. That's our build, and we're going to run through some activities against that build that we've performed. Continuous delivery means that we've taken that software build, that process extends into the world where it can enable delivery of that software to the next environment that we want to deploy to. And if I take a standard enterprise, very, very simple, I'm going to say I have, okay, very basic and simple. I'm going to say 4 environments that I'm going to deploy to. 4 environments. Well, I've got dev, I've got integration test, I've got user acceptance test, and I've got production. That's 4 environments. Now, the reality for all of you, you'll have way more than that. There's the operational acceptance test, the user acceptance test, there's the performance test, there's the system integration test, there's the keep going. You can have more and more and more. The most I've ever worked with is a customer who had 19 environments from the code change to production. Pretty complicated, but they had it for specific purposes. For example, where they needed to deploy application changes to pilot environments to run them through to get some kind of blue-green testing going, but they wanted dedicated resources to work against it, as an example. Continuous delivery and continuous deployment, 2 slightly different things. Continuous delivery means the code is ready to go to the next environment at any point in time. Continuous deployment means our code change happens, it gets deployed to an environment, we automate the steps of validation, and we automatically deploy it to the next environment, and the next environment, and we validate, and the next environment, and we validate, and we get to production. And continuous deployment flows that change all the way to production. So make sure that everyone's on the same page when we're talking about CD. CD being continuous delivery in today's example, as opposed to continuous deployment. What else? Well, people talk about pipelines, and they talk about builds, and they talk about deployments. They're all slightly different things. We'll talk about builds first. It's in the middle. It's the core for CI/CD. We're performing our continuous integration build. It happens when we commit our code. Our build happens. We don't have to do anything else than build. If we're talking about a C build with a makefile and produce our exe. If we're talking about a Java build and we're running our Java compiler and we take our Java file and we maybe run it using a Maven build and we end up with our WAR file or our EAR file or whatever we're building towards. So our build process, pretty straightforward. Our deployment process, pretty straightforward. We're taking an application that we've just built and we're deploying it to its next logical environment. And we're automating that deployment and we're making sure that we don't have to have any human interaction. Why? Because human interaction is the thing that introduces risk and causes problems. So we're deploying to our environment. And then we're taking our pipeline of linked activities and steps and saying we go from a build to a deployment, we execute some code, we go to production, we take our end-to-end set of steps and activities, and we define it as a pipeline. So we make sure we're on the same page. Automation of test, automation of build, automation of deployment, automation of verification, automation of feedback, automate everything. Make sure everyone's on the same page when we're talking about automation. And then, of course, simplification. How do we simplify what we're delivering? How do we simplify our application structures and our architectures? And finally, how do we define what success is? What is a successful implementation of CI/CD? Because we're looking to drive those benefits. We're looking to get ROI and improvement from the changes that we make to implement CI/CD. And then, of course, the other challenge when we look at technology, how many tools are too many? We talked earlier on about this notion of the more tools you have, the more complexity it is. The challenges of standardizing feeds and data, the making sure that the systems are communicating directly. Every time we upgrade one tool, what's the risk and the impact of all the other tools in our tool chain? But the converse of that, what if I simplify my tool chain? What if I simplify my tool chain too much? What if I take away components that I need in there? How do I simplify so I go from 10 tools down to 5 tools? And when I standardize and simplify, how do I make sure that I'm not losing the value that I've built up over the last few years with my different tools in my tool chain? And likewise, how do I get consistent metrics? How do I ensure that the metrics that I'm delivering that track and trace the benefits of implementing CI/CD are consistent? Or how do I make sure that I'm getting consistent metrics across all these different tools in my tool chain? What we'll find is the fewer tools in the tool chain, the more simplistic and the easier it is to generate standardized data and to get an end-to-end view of what's happening in our environment. And then finally, how do we tie security into all of this? So let's think about simplification. We need to align our technology. We need to align our terminology. We need to ensure that everyone's on the same page when we're talking about CI, CD, build process, deployment, automated testing, automated verification, dynamic application scanning, security scan, peer review. They need to have a definition of what each of those are and tie into a single location that everyone in the company can understand. And then we need to try to simplify our tool chain. Simplify our tool chain to the lowest number of tools that can meet your requirements. And every organization is different. I wish I could say that one size fits all. It really doesn't. Every organization has its own dynamic. Every application within an organization have its own dynamic. There are reasons that certain tools are applicable for certain applications and products in the organization. Maybe they don't need to be modernized. Maybe they can't be modernized. Maybe the working practices of the teams mean that the dynamic is too small to be able to scale to what we're talking about. So look at the lowest number of tools that you can use across your application first, and then across multiple teams within your application, because that ties into our ability to scale. Let's think about scaling. I mentioned some of the challenges of this earlier on, so we'll do a quick question on this one. This is the last question, I believe. Hang on, you need to scroll through the slides to remember if I put another one in. I think this is the last question. So the last question is, I have the visibility and insights I need in order to see exactly where our processes need to be improved and what steps to take to do so. So let's think about this whole process improvement. If I want to improve my developer processes, my CI/CD processes, do I have the data to be able to do that? How can I simplify my processes? How can I reduce the number of tools? How can I understand where my bottlenecks in my processes are? So a question for the audience, true or false? Do you have the visibility and insights to see exactly where your processes need to be improved and what the steps are to improve it? Okay, so simple answers this time. Rather than one or two, it's A or B, and it's true or false. So true, I have the tools to enable me to understand where I can improve my processes. Or B, false, I do not currently have the visibility or insights across all of the different tools in my ecosystem to be able to allow me to do that. Okay, we'll run for, once again, another 15 seconds. Same question, visibility and insights I need to see where our processes need to be improved and what steps needed to do so. So like I said, that's answer A, true, answer B, false, and we've got 5 seconds left, so get your final votes in. Again, we're doing pretty well on the responses, so excellent. And we'll call it in 3, 2, 1, and there we go. So there we go. So almost, I guess it's a relatively even split. A little more than half of you saying you don't have the visibility and insights to be able to improve the process. And I guess the key around that is understanding where the bottlenecks are. So being able to say, okay, my tool's not providing me the insights that I need. What can I do about that? How can I improve my tooling? Is it something that I can change within the tool itself, or do I need to look at alternative tooling? Do I need to look at a slightly alternative approach for my process? For those of you who say true, okay, excellent. So what we can then do with those of you who have said true, you're getting that visibility and insights. How do we go about process improvement? How do we look at process improvement to change the organization? And remember, this is going to be a big impact. There is change to the organization happening. So how do we change the organization to be able to get the benefits that we need from our processes? And that could be streamlining, that could be simplifying, that could be adding additional information feeds, that could be anything from trying to remove the complexity of process to reducing the number of touch points that individuals have to have through automation. It could be building new practices into your processes to simplify them, which sounds like an oxymoron. How can I add more to make it simpler? Well, if we're adding security into our CI/CD and pipeline processes, we're taking away the complexity of a separate security organization later on, validating that everything's okay, for example. Same with performance engineering. If I'm looking at including performance tests into my CI/CD processes, I don't need to have dedicated performance engineering take place later on to validate that my application can scale in production. So how do we make those process changes? There's a lot of process engineering and application architecture and enterprise architecture work that happens to tie into that. Okay, excellent. So we're on the final leg, I guess. Let's talk a little bit around disconnected and siloed information. You all understand the challenges around this. Having multiple tools in multiple places with multiple teams working on them causes a silo of information. What you really need is to become the super communicator for your organization, which in turn will help your organization super communicate. And that super communication drives changes and improvements in process, people, culture, and it drives improvements in the ability to collaborate across the organization. I don't mean super communicate by posting that you had a party last night with your friends and everything was great. I mean super communicating with the things that make a difference to the organization on the day-to-day activities they perform. Being able to understand that your business area and another business area are intrinsically linked, and making sure that they're fully aware and fully au fait of any changes that are happening in your business that affects theirs. I see this a lot of times. Organizations don't communicate across silos. They don't communicate within business areas across different teams. Maybe your development organization isn't talking to your product group. Maybe your product group isn't talking to your operations team. Maybe your operations team doesn't communicate correctly with your professional services organizations. So we need to tie that together. Process. So improving insight and collaboration, making sure our team goals are aligned across the business unit and then across the organization, making sure everyone has a common understanding of terminology. When is done done? When is my organization's work done? And how does that implement and impact other business units? Making sure people understand application shift left and how we deliver products to production. And then finally, what do we do from a technology perspective? We need to understand where are my servers to implement CI/CD. We mentioned the spin up of new infrastructure. How much is it going to cost? Where are my dependencies across my servers? How do I include security in my DevSecOps processes? How do I make sure that my user acceptance tests, again, when we're driving CI/CD and we're getting user acceptance test environments ready relatively quickly, how do we make sure that those UAT users are notified? Because there's a cost to the business of bringing them in to validate our product changes. So how do we notify them as early as possible so they can book the time that's needed and available to them? And how do I ship my applications? How do I shift them from traditional application architectures maybe to Kubernetes? Or how do I SaaSify my product if need be? How do I go down a container-based delivery and deployment route? How do I make sure that my organization understands the need for technology shift to support my CI/CD practices? So what do? We take our processes, we say, this is my target architecture, this is where I want to get to, this is how I simplify my application delivery, this is how I understand the costs for that shift, and this is how I take my metrics for making sure that I'm tracking how I get there. So getting that ROI and making sure that the metrics that I've put in place actually track the ROI that I need. And then I guess our final pitfall as we look to wrap up in the next few minutes, looking at changes to culture, making sure that it's driven top down and bottom up from a transformation perspective. We said earlier on there was about a quarter of people who had challenges with leadership and not buying into this notion of CI/CD. How do we get leadership to align with the goals and objectives of transformation? If the business is saying we have to deliver faster, how do we make sure that leadership understands that delivering faster is tied into a technology shift around CI/CD and a cultural people and process shift of DevOps transformation? How do we have a communication plan, and how do we put a communication plan in for execution? There's no point in someone at a leadership level saying, hey, let's go and do CI/CD if nobody understands what that truly means and how it will apply to the individual products and the individual teams. How do we have the right level of ownership? In the agile world, we have the notion of product owners. How do we have product owners and technology owners? Because there's no point in trying to define CI/CD process and practices if we don't have the technology to support it in place. We get stuck in this continuous loop where we're trying to define change and implement change as quickly as possible, but unfortunately, we don't have the technology to support that. And then how do we build a process and a culture of learning and trust within the organization so we can try this out and make mistakes? The key being fail fast. It's not just for the applications, it's for the technology shifts that you make. You have to be prepared to fail occasionally and then rework that as quickly as possible. Go in a different direction. Maybe you start with a platform aiming at one set of capabilities and market space, and you quickly shift it to move to another. Why? Because you see the market dynamic adjust. And then when we execute, let's make it achievable. Let's make it small steps. In the same way that we plan to execute software in an agile way in small incremental steps, make your CI/CD transformation incremental. Start with continuous integration, getting your build processes per team, per business unit, and then across business units in place. And then transform that from CI to continuous delivery. Take the feedback on board, especially when you have a culture where people don't want and don't like change, which is most organizations. How do we ensure that the concerns are taken into consideration properly? Let's look at the technology, how we shift to it, and then let's educate everyone across the board, making sure that everyone understands the benefits that we're looking to drive long-term, aligned with the business goals and the business plan, and ultimately the success of the organization. And make sure you over-communicate everything to drive that super communication across the organization. And remember, it doesn't happen overnight. CI first. Look at your build processes, your build practices, your technologies, making sure you've got the infrastructure to support it. Once you've got your build processes and practices in place with a vision for building towards CD, build out that CD component. Your GitHub actions, your deployment automation, your continuous delivery processes, pushing into environments, your automated testing, your automated feedback, your automated security scans. Make sure all of that comes back in and drives the communication of change. So as we wrap up, what are we looking? We're looking at identifying what we're trying to do and the benefits and gains that we'll make. We're defining our initial ROI. And remember, that'll dynamically shift as we look at the benefits that we can drive. Analyze the costs and the impact. Don't do it if it's going to cost you more than your organization can afford, or it's not going to drive the benefits. And then look at the people, process, culture, and technology impacts. Simplify tools and processes. Reduce the complexity across your end-to-end set of software delivery lifecycle capabilities, and standardize everything. There's no point in every business unit doing things differently. Within a business unit, do it the same way, standardize your technology, process, and culture. Within your organization, once that's been successful and proved, do exactly the same thing. And then finally, optimize. That continuous process improvement, optimize what you have. Just because it's working doesn't mean it's optimized and doing the best it can. So optimize everything around delivery and execution. Wow, that was a lot of information for a very, very brief 1 hour webinar. Hopefully that was beneficial. We'll jump now into Q&A. So if anyone has any questions, comments, or concerns, feel free to yell them up now in the questions. And Melissa, back over to you.
Awesome. Thank you so much, Julian. That was very insightful. A lot of information. I'm glad that we'll have the on-demand recording because there's some things that I'd like to go back and dig into. We have had some good questions come in. Before we go there, I just want to mention that we do have some resources available to our audience. So I'll go ahead and leave those up on the screen while we do our question and answers. And if anyone does have any last questions, feel free to continue submitting. We'll go, a couple minutes over. If anyone needs to leave, that's fine too. All right, so I will jump into these questions. I'm going to actually combine a couple because they're sort of on the same topic. Is there a way to start slowly or incrementally, and where would you recommend starting?
Yeah, as we mentioned, I think you look at your applications within your business unit. You look at the ones that are maybe more technology aligned with implementing continuous build processes, so that CI component. You look at the technology that you currently have. How does that code commit trigger the build? You start with that, you get your CI processes refined and defined, and then from there, you move into the continuous delivery phase and say, okay, what do I need to add to my steps of my build process to allow us to do that? Now, of course, OpenText has some great technology and Pulsino to allow you to do just that. Start with the simple and then extend it out into the steps and capabilities to drive continuous delivery on top of that.
Awesome. Thank you. I'm going to ask one more because I think it speaks a little bit to this stakeholder problem. Do you find that CI/CD, I'd love this question. Do you find that CI/CD creates more work for everyone?
Actually, no. The funny part is that the CI/CD actually reduces the burden on individuals. Why do I say that? Because when you implement CI/CD successfully, you automate a huge amount of work out of your processes. If I look at the traditional world, you're building code, you're moving artifacts around, you're setting up systems for delivery and deployment, you're running a bunch of manual tests, you're running a bunch of performance tests, you're going through a number of non-automated steps. When you implement CI/CD successfully, not only are you automating your code commit build process, but you're automating that entire end-to-end session. The code commit, the build, the test, the validation, the performance engineering is done as part of your steps. The security scan is done as part of your steps. The transition between the different parts of the pipeline, the different users and the different groups is all automated. So you actually reduce work for everyone as opposed to increasing it.
Awesome. Thank you so much, Julian. I appreciate your time today. To our audience, please note that we will have a replay of today's event that will be available on demand shortly. Unfortunately, that's all the time that we have for questions, but thank you all so much for your great participation. If we weren't able to answer your question today, we will respond to it directly by email. And of course, with the online on-demand event, we invite you to share that with your colleagues, or like I said, go back and rewatch it. Thank you again to all of you for your attendance. And of course, thank you to our speaker, Julian Fish. This does conclude our event. So I hope you have a wonderful day.
Thank you all.